To the first roundtable of this afternoon, Part 2, Agricultural Robots, a Global Market. And this roundtable will focus on agricultural robotics storms, global markets, and I'm very happy to welcome on stage our moderator for this session, Sinead Byrne. She's accountant and business analyst for the Yield Lab Europe Fund. Please welcome her.
Hello, how are you? My name is Sinead Byrne and I am from the Yield Lab Europe Fund. I'll be your moderator and I'll introduce our panellists now. I'm going to give you a short overview of what the Yield Lab Fund is. So basically we invest in high impact ag tech startup companies. So we run an accelerator program every year where we take in 5 companies and we basically give them 100K. 75 in cash and 25 in service in kind. So we are a bespoke accelerator fund in that we work with the company and exactly what milestones that you need to reach. And we will stay with you. We have a larger fund which is 21.5 million. So we have money to further invest in the company to bring you the whole way up to full commercializations. If you could move on the slide, please. Slide, yeah. So we're a global fund and we have offices in Europe, North America, Asian Pacific and LATAM at present. To date, worldwide, we have invested in 45 companies around the world. We bring a vast amount of experience and knowledge to each portfolio company and we support them during their journey by mentoring and introductions to key players in the industry. So the agricultural robotics markets worldwide is projected to grow by a CAGR of 39% between now and 2025. This is driven by our natural resources, such as land, labour and water, and the limitations. By adopting technology will emerge as a key of improving agricultural production to feed the increasing masses. Given this scenario, ag robotics will likely play a vital role in the stages of the agricultural cycle, such as harvesting, watering, sowing and seeding. So I'd like to bring up our panellists so that we'll be able to discuss this further. Sorry? Yeah. So we have Suresh from TAFE from India, and if you'd like to explain a bit about your company.
Hello everyone, very good afternoon to all. Myself Suresh MURUGESAN, associated with the TAFE more than 15 years, currently working as an assistant chief engineer, precision farming projects, heading connected and autonomous vehicles as well. About my company, TAFE, Tractors and Farm Equipment Limited, is an Indian tractor major incorporated in 1960 at Chennai, India, with an annual turnover of 1.3 billion US dollar. More than 5 decades of experience in designing, developing, manufacturing, selling, and supporting of tractors in diverse soils and agroclimatic zones. TAFE is the 3rd largest tractor manufacturer in the world, exports more than 100 countries, and 2nd largest tractor manufacturer in India by volumes. Holding almost 25% of the market share with a sale of 150,000 units of tractors per annum. Strongly backs with the 4 iconic brands, namely Massey Ferguson, we call as an MF brand, TAFE brand, Acer brand, and recently we acquired a Serbian brand IMT. TAFE earns the trust of customers through its range of products and services more than 5 decades for best in quality and low cost of ownership. TAFE is also a significant shareholders of ACO corporations. It's a stellar example of, it's a 58 years of partnership with ACO corporations in USA. It's a stellar example of long-term relationship with the stakeholders through its fair, ethical business practices. Today, TAFE is one of the leading manufacturers in the world. 1 in every 10 tractors sold around the world is TAFE tractors. Last but not least, TAFE, in its journey of cultivating the people, cultivating the values, cultivating innovations, thereby cultivating the world. Thank you.
Thank you. Christian, would you like to do a short introduction?
Thank you. Thank you for being here. My name is Christian KIRCHHOFF. I'm the owner and manager of the K.U.L.T Cress company. The company was founded in '89 as a company helping organic farmers modify tools, find tools for organic farming, which was a big thing at this time in Germany, in a very fast-growing market. So we were in the harrow business, selling harrows to organic farmers, and we did a lot of field training. The company today is 30 person. We manufacture outside. We are in the Stuttgart, Germany area with a lot of expensive industry, so we do not manufacture ourselves. We buy everything and we design and engineer our parts at home. And selling all over the world, mainly Europe, United States, North America at all. Our focus is weeding equipment, especially we are very keen on working in the zone right beside the plant row. I think many people know our system, the so-called Cress finger weeders, where we have fingers, you can see that down in the exhibition hall, yellow fingers out of plastic working inside the plant row by moving the soil around the plants. So this is one of our tools to work close or even inside the plant row to do a good mechanical weeding job. Later, like in the year of 2002 more or less, I was very interested in all kind of electronic, started with camera, vision-based steering of machines, GPS equipment, steering, rear-mounted machines behind tractors with GPS, following with cultivators, and so on. Today we are at the stage where we work with in-row tools, vision-based plant recognition, tools which open and close inside the plant row and work between the plants. And we are really waiting for the next step of intelligent systems really, which are able to detect and find out the difference between good and bad plant, I would say, weed and crop. One word more for concerning robotics and what are we doing in robotics. We are importing the NAYO robot in Germany, so I know a little bit about the market, how to sell a robot and where are we successful, where are problems, stuff like this. We are also preparing the next step of, I would say, a machine which can, how should I say, it's the wrong approach. We started making tools for tractors where in '89, where the tools were belly mount. Then it got every time more heavy. Now we are back to small tools and do tools for robots, lightweight, simple, effective. I think you can see that in the exhibition hall, and I wait for your comments later on. Thank you.
Now, José, would you like to?
Hello, everyone. Thank you for being here. for us as HORTIFRUT. It's a pleasure to join this roundtable. My role at HORTIFRUT is being the CIO, the Chief Information Officer. And as HORTIFRUT, we run the business to produce berries. We produce berries in about 40 countries around the world. We sell them to the 5 different continents. So we are the largest company producing berries. In the DNA of the company is innovation has an important presence. That's why we are here. That's why we are trying to see how can be innovative in the robotics side as well. Actually, we are doing some project around robotics. Also, we are trying to work on preventive monitoring of our crops, and doing also some research regarding how to apply robotics for harvesting and automate robotics harvesting solution. I believe that FIRA is a great place to be and to connect and make connections and collaborative works around robotics.
Thank you. Peter?
I can take this microphone. So actually I have planned to give a slide presentations, but we decided to withdraw slides and to introduce just by words. And I think I don't have to introduce my company. It's John Deere. Everybody in the room knows it. My task in John Deere is I'm located in Kaiserslautern and I'm doing research work. So we are a group in our building which has the right and the task to look into the future. So our projects are not dedicated to bring anything to market on short-term notice. So one word about my company. We are not only an agricultural machinery producer, we also produce construction machines. So, and many tasks here, when we speak about robots and autonomous machines, many tasks, technologies can also be adapted to construction machinery. We in my group, we focus on electrification and we also focus on automation. This includes sensor technologies and also autonomous operation. And yeah, I would say I'm a production engineer originally. I would say that an agricultural machine is, from my point of view, something like a machine tool. So we also do some research work for our factories, and we want to introduce technologies of Industry 4.0 into our factories. And we see agricultural production in many ways as being a parallel, an analogous system to a manufacturing system. So this is why we try to implement something like agriculture 4.0. We see precision farming as an automation tool in the sense of Industry 4.0 with the machines just as a part of the system. And finally, last but not least, you might be astonished, we are also still doing some work on combustion engines because we believe that the next 10 years will still need some combustion and machinery, some combustion engines. Thank you.
Thank you, Peter. Now we will have Rohan.
Thank you very much for the organisers of FIRA inviting me to come to this conference. I've come a long way, just to share with you, 39 hours to get here. So if anybody wants a trip to Australia, come home with me. But I'm a director in a company called AGTECHCENTRIC, which is primarily made up of me and my business partners, where we're primarily helping industry, particularly producers in Australia, navigate the introduction of new technologies to the agricultural sector, primarily working with government and addressing the regulatory challenges and concerns that we have. Just to give you a bit of context about Australia is that we have very high rates of what we call no-till production, where we don't till the soil prior to planting, and that has revolutionised Australian production and has actually meant that we've been able to withstand drought in our country, which has been particularly bad this season. We also use controlled traffic. The majority of tractors are on 3-metre centres, and we apply those to permanent wheel tracks in the field, and we use real-time kinematic or RTK auto steer to 2 centimetre to help us deliver those outcomes. 85% adoption in Australia, it's been huge, and Australia was one of the first countries, well, it actually was the first country to actually see commercial application of auto steer in the field, and it's been widely adopted and it's become very popular, and Beeline was the first company to commercialise that. Auto steer is very common in Australia as well, also around 85% adoption. It is standard practice now in Australia, and conversely that creates some challenges to us with boredom. Most recently we've conducted a national review, I suppose, of the digital agriculture opportunity in our country, and while there's some massive opportunity, the value to labour saving in agriculture industry is estimated around 7.4 billion Australian, so you can roughly halve that for euros. And it's quite a significant value. But with that, if you look specifically at the grains industry, the labour saving value is well in excess of 1 billion Australian dollars per year, and we can see some potential value to that in our industry. And again, that's roughly about 550 million euros. Quite significant. I suppose just to share with you that the challenge that we've been working recently in this country, in Australia, is the use of autonomous spraying. 90% of the demand, we think, for autonomous tractors will initially be for spraying, and that creates its own challenges. And some of you may have heard of the company Swarm Farm. It's actually now commercialising in Australia, and Andy Bate, who's had a very successful company based in Queensland, is commercialising that product today. But we do have some regulatory challenges with the use of commercial spraying. But where we see autonomy in our country, it's going to be a game changer. Not so much it's just going to reduce labour cost and production efficiency, but it's going to really provide us with new ways of farming in ways that we haven't seen possible. And we've already seen that with the introduction of auto steer. It has actually changed the way we farm in Australia. And we're going to see more change in the next 10 years. So just a thing to share with you, this is the last slide, is Australia's actually market ready today for full autonomy. And it's probably one of the ideal locations to commercialise first, because we actually have very few regulatory barriers to on-farm autonomy. So if you're interested in doing some business in Australia, come on down under.
Thanks a million, Rohan. We're now going to put a few questions to our panellists. And one of the questions that was sent to me was, what is the next robot? Is it big or small? Who would like to take it on? Okay, Christian?
Hey, yeah. I think both is right. We will have small and big ones. As I said in my short introduction, we have already big ones in the field, maybe more than small ones at the moment. If you consider a GPS-guided tractor with a big implement, more or less self-driven, autonomous, the only hint is there is no rules, except for Australia, maybe, how to run it in the field, really. It's not allowed, that's it. The technique is there, so I think we have more big at the moment than small robots, kind of robots. As I see it from my point of view, we have already customers using them like robots, even when it's not allowed. So maybe you would comment some, I saw some interesting images from Australia with big tractors, self-driven, self-turning. Maybe you can comment that.
The Australian market is market ready for large-scale tractors between 250 and probably 450, 500 horsepower. There's a market readiness and industry demand for that today. However, I do agree that another good Australian term is it's horses for courses. And in some applications, and small platform robotics are going to be particularly useful, particularly if they can be self-powered using solar panels and run continuously 24/7. I think that's one of the key advantages in our environment. Because of our remoteness, the requirement to have to go back, service, refuel, maintain equipment becomes an issue. And so a small platform robot actually is self-powered and self-managing. That actually provides a significant advantage.
In agriculture industry, if you see that uncertainty leads to an opportunity. When we move forward, we see the futures. I'm talking about in India. I'm just give a statistic about the Indian farming. 85% of the farmers are holding less than 1 hectare. And the 50% of the 15% of the farmers holding more than 4 hectares. What it says. Today, the mindset of people has changed. 10 years back, robotics, if you say, oh, it's like a research project, it's a college project, it's an institution project, it's maybe a tie with some kind of governments, we have to do it. It's like a proof of concepts. But when it comes to the reality, today, everything is changed. We see a lot of projects, we see a lot of product which is running in the expos. It's really good. What I want to stress here is, when you talk about the world globally is talking about the compaction, people are changing their mindset from bigger to the smaller. The reason is the compaction, the yield which lost due to the entry of the big machine into the field. And if you really focus more on an Indian market, I could say small robot will win the business.
So we have small in India and big in Australia.
So my opinion to your question is what is next, small or big? I personally believe it depends on the frame conditions. So I think the chances of the small robots are big where they can replace manpower. So human workforce can be replaced. It will be hard for the small robots to replace bigger machines. Therefore, I believe that the field, or the primary, not exclusive field for applications of small robots is in the field of high-value crops, where you have small structures. You have also long periods where you can react on something like diseases. You have a lot of workforce still today which you can replace, but the productivity in standard arable farming with the standard machine sizes is so high that it will be hard to achieve a new level of productivity with the small robots. Therefore, I believe in standard arable farming, the big machines will have a long lifetime still ahead of us.
Thank you, Peter. We just want to talk about the challenges that robotics are for farmers, and we discussed, the high cost of them, the high installation cost of them, and also the adaptation. And because we are here from Australia, Germany, India, and Chile, can I have your thoughts of how easily it would be in your country to adapt to it, and how would the farmer justify the cost of robotic equipment at the moment?
When you talk about India, there are 3 challenges: availability, adaptability, and affordability. Availability, we can say that, I think a big machine, if it breaks, what is next? The same machines can take, the big machine is replaced by a number of 5 machines, it will not affect the productivity or it will not affect the field works. When it comes to the affordability is a big question today. People can't afford the technology. So we could say, normally we could say, we need a Japanese machine at a Chinese price. That's what the people are keep on asking us when we are get the project. And adaptability. Adaptability is a big question today. So if you see the farming community in India, the average age of the farmers are 50 plus. So we foresee, I think there are a lot of demand. This kind of technology is going to create the youngster to bring in the ecological business. So moving forward, I think we see only the 3 challenges. I think cost is the biggest challenges. And if you make farm as a service, morning we have been discussing, that's the biggest, is really a good business model. To seed the technology, thereby we'll get the business over that.
It's interesting that curve or graph that I showed of the adoption of auto steer in Australia, when the price point hit about $50,000 Australian, so about 30,000 euros, the adoption rate just accelerated exponentially. That was the price point in Australia where we saw real change, and we foresee that with the introduction of an autonomy system onto an existing tractor in this country, at that similar price point, we'll see a similar rate of adoption in Australia. That's what the speculation forecast is. That's for large tractors. On smaller platform robotics, it's early days. We'll have to wait and see what the relative cost of adoption, but it comes back to this question of capital investment versus return. And the change to no-till systems delivered about a 10% yield improvement. The change to controlled traffic delivered about another 8 to 12%. Auto steer was a major contributor, which in effect, with reduced overlap, added another 8%. So you add all those factors up, they become quite significant. And more importantly, it actually changed the whole way we farmed in our country. I think the thing that we have to understand from robotics is it's not so much the innate cost up front, but it's what it can deliver in terms of productivity benefits through the complete change in the farming system in the longer term. And I think that's where we're going to have to explore how we use robots, is actually how we can actually adapt our farming systems to more efficiently use the robot itself.
Talking about the farmer standpoint, to answer your questions, I believe that there are 2 keywords, productivity and quality. If we can have a robotic solution that can be more productive than the manpower and also can harvest or doing farming works better than human, are the most important things. Cost, it is an important topic. However, I believe that robotic, or the way that robotic can be sold in the market as service, can manage that part of the equation. But productivity and quality is critical when we talk about the farming and the crops where we are in the berry industry.
Would you like to say anything, Peter?
I think the business model is important. Nothing will take place without supplying to the customer, to the potential customer, a business case. Otherwise, it will not work. So you have to prove to the customer what you give into his hands before he purchases your product, and he must believe and trust that this creates a profit for him. I think this is the story behind it. And coming back to my last comment on the big and small machines, and consider the situation: you have a seeding robot that brings out a set of kernels. You will bring back 50 times or 60 times as much kernels. So this means you need some big machines, which, by the way, are operating quite autonomously today already. So you need big machines. So the robot that does seeding, perhaps plant protection, and perhaps also some fertilizing, is an on-top thing on top of what you have anyways. And you need some bigger machines also for soil tillage and all these work. So it is quite complicated. If you don't replace workforce, human workforce, it is quite complicated to create the business case for the farmer. And this is finally what is the only thing that is important, business case for the farmer.
I would agree that what you said before, that the high value crops are the first ones as customers which would be interested really in robots. It's also like vegetable business. They work 6 months continuously. You plant lettuce every week, you harvest every week. You can run a robot like permanently and not only for one short season, like 3 weeks for cultivating sugar beets or whatever. No, this is the first approach, I think, for the market. But I come back, the hardest or the biggest issue at the moment from my point of view is security. If we would go around the security question, we would have a lot more robots already in the field. When we look over the different countries in Europe, we see and that's the reason why we are in France, I think, that in France there's a lot of support, also financial support, to help farmers to invest in this field of technology. When it's only driven by economic decision, it's at the moment very hard. I think the business model would be run like 5 smaller robots, like one tractor width or whatever, like 5 in the field, survey all 5 of them, and you would immediately make money. But that's not possible at the moment, and that's a big hint. When I talk about United States, we have the same problem over there. Drivers can't step down from the tractor, it's not allowed to turn on the road, a robot, so this is the biggest issue from my point of view.
May I add something? Yeah, I fully agree that the biggest issue is safety, and let's rephrase it. In other words, the biggest issue are legal frame conditions, because we can run our machines already autonomously since 15 or even 20 years ago. According to SAE J3016, we have reached more than a decade ago autonomous level 3, and it would be really easy to remove the driver completely from the machine with regard to technology aspects. The only thing why we can't do it is legal frame conditions, safety issues, etc. I personally believe this will change, because with upcoming autonomous driving in on-road traffic, people will learn and accept that autonomously operated cars and later on machines are safer, much safer than human guided machines. And as soon as we have learned and accepted this condition, while we of course will never have an absolute safety, that is something we will never achieve, but as soon as we accept that the autonomously operated machines are safer than others, the frame conditions from the legal and safety side will change, and as soon as this happens, we will have autonomously operated machines. And I would give a forecast that this will happen in the next decade. So we are very close to this point. The technology is already there. And one more word to safety. If you look to accidents in agriculture, most accidents happen to the operator of the machine. If I get rid of the operator on the machine, I create a much safer system compared to what we have today.
José, would you like to?
Yeah. I respect the opinion, but I wouldn't agree. I believe that always technology go first than regulations or safety. So I take in account your point, but I believe if technology is ready, are productive, and with quality, and it works well, regulations will move forward. So in my view, it is a topic to have in account. But for me, in my opinion, first technology, robotics need to be ready, and so far it is not.
In Australia, our experience in terms of autonomy has very much come out of the Australian mineral mining industry. And it's quite a controlled environment, but one of the challenges that we're experiencing in Australia is actually a shortage of labour, quite specifically. It's not so much if you can afford to pay the cost, it's actually being able to find people to actually come out and work in remote areas, of which agriculture is in Australia. Our farms, just for example, the top 4,000 farmers in Australia have farms in excess of 10,000 hectares, so they're quite large and they're quite remote, and that creates its own challenges. But what we're seeing in Australia is a corporatisation of farming. So many of them are family-owned businesses, but they're becoming very large family-owned businesses and become much more structured in the way that they operate and train personnel and operate their business from a safety point of view. And it's particularly those businesses that are seeking to go the next step from using auto-steer semi-autonomous systems to actually removing the operator and the tractor, principally because the operators are getting really bored in Australia. They haven't got cell phone or mobile phone connectivity. There is nothing to do on these tractors for days on end, and so it's becoming an issue in terms of just staff welfare to think about longer term of removing them from that environment and providing them with a much more sort of positive task of managing an equipment fleet.
So it's replacing manual labour with a robot. Great. One of the key things that I'm hearing here is that basically in every different country, and I know this will be discussed in the next one with the legal requirements of robotics and it being illegal to use them and the insurance aspect. How do you think it will be dealt with? Because what it seems to going to happen is that every country will have their own standard. Should it not be worldwide uniformed for robotics and it put in place now so that the technology that we have in place can start being used?
I would agree to what you said. Car industry ready, robots are ready. That's it. If the car industry is really ready, then there's all legal aspects more or less solved, and it's done. And I do not agree what you said. There are no robots. There are robots. You could start immediately, not for all crops, but for some crops they are there, and we have customers running them, I would say. So it's possible. But maybe it's not for all different purposes available. So there's a lot of things to do for sure.
Yes. Yes, I agree with your comment. First, there are some robots for some farm activities. However, in the industry where we are berries, today there are not robots available to buy them. Okay, and making some farm activities in a robotic way first. And secondly, I believe that the most important farm activity that we want to pursue to automate is harvesting. And probably this is very complex activity in the berries industry and in all the crops industry. So the answers are not black and white, I believe, but you agree. There are some development of robotic solutions, but still some crops more developed or instead of others that are less developed. But for me, the end goal in all crops is trying to automate the farming processes, and we are not yet there.
I would like to give a comment on your question regarding standards, a very principled comment. The question is, are we in a phase of technology development, upcoming technologies, or have we a technology ready for deployment? I would say we are still in a phase of technology development, and then in such phases, standardization would create obstacles, because standards always freeze technology. They are backwards oriented. If a technology development is finalized, then you can consider standardization in order to increase the deployment of a ready technology. I would say, although we have almost technologies to run machines autonomously, you may also call it robots, we are not at the end or near to end status of our technology development. So I would not consider standardization processes currently.
So in saying that, what is everyone's opinion of when exactly we will have robots ruling the ag? You know, you're saying that it is there and that there's ones running, but they're illegally running. So what is the time frame?
If you ask me, I think there is a need of technology. If you ask me now, the need is yesterday, I would say. But I agree with his point, because robot is not only a selling. I mean, again, I want to reinstate it. It's not a product to sell and forget. It's not like that. See, there are behind the story you have to see. We are selling this product to an agricultural environment where everything needs to be done within the time frame. If you miss the time frame, the farmer will lose the entire crop. Why the regulation is not at come? Because the maturity of the robot, it's not on that level today. The technology is proven, it is very good, working perfect in front of a mechatronics engineer. But in front of, think about the farmers. If it doesn't work, when he want to do the weeding at the weeding cycles, what's happened? Weeding is contributing almost 30% of the yield loss. If it is not working at the time when the farmers need, then where we are? So there is the regulation and standardization is going to be a big thing once the product is ready. Ready in the sense in all the aspects, when the spares is ready, when the service manager is going on time, because it's not like that, no, there is a vehicle, we can park it and we can come and take it afterwards. But Agri is not like that.
May I come back to your question? I had the feeling that you addressed directly me. So actually, I don't have a crystal ball.
No.
But technologies often, in many, many cases, develop slowly, and once they come to a turning point where the growth, this very slow growth, turns into an exponential growth, and I don't know exactly where this point is. I would expect it to be in the second half of the next decade. This is my prognosis, but as I said, no crystal ball on my side.
All I can say is from Australia's point of view, technically commercialisation has already started in Australia of fully autonomous, and when I mean fully autonomous, no one present in the field. So they're getting remote telemetry telling them if things are stopped or going otherwise. But I would go so far to say as I think 2020 is really the key year for Australia in terms of commercialisation. Principally because of market readiness, and one of the factors for that is that autonomy, in effect, gives a producer more patience because they don't have to sit there on the tractor all day to do some tasks, and it means that we can perform tasks that otherwise just weren't possible before. And one of those important tasks for us in Australia, because we export 70% of all the food we produce in Australia, we're exporters. We don't consume it in Australia, we export it overseas, and to meet the market requirements of those overseas markets, the major driver for us is reducing pesticide use at the moment and reducing pesticide residues on food. So technology that helps us achieve that is a key part of that, and autonomy and robotics is going to be a very significant factor in achieving that outcome, whether it be broadacre grains, the vegetable industry or viticulture in Australia.
Answering your question, if I take a positive attitude, I could say that it will take place between 3 and 5 years. If I would say that negative attitude will be between 5 and 10 years. But at the end, we are not talking about so many years. If you see the amount of investment that are behind the AGTECH is enormous. It's huge investment. The 2017 it was about 10 billions. Last year it was about 16 billions, and probably this year will go over 20 billions. So there are a lot of investment behind of it. So in my view, that will push technology, that will push the development of robotic solutions, and that's why I would say that between 3 and 10 years, we will have robotic solutions in the farming industry, for sure.
Okay, before we take any questions from the audience, would any of the panelists like to discuss anything particular about the robotics? Peter, have you anything?
Yeah, if we speak about robotics, or as I preferred, about autonomous working machines, mobile working machines which are running autonomously, I would come back to the view on the automotive, the on-road automotive sector. So what is our anticipation how fully autonomous cars could go on our streets? I would say one scenario that I could imagine is that we will have a driver, which is an analogous word for operator of an agricultural machine. So I guess we will have, on the long run, we will have a driver, but the frame conditions will give us the freedom that the driver does not necessarily have to be on the car itself. So I could imagine that the future of autonomous cars is that we will have operation centers where one operator drives a fleet of cars. This is a very realistic scenario, which I at least believe is realistic. And I could imagine that we have afterwards, after this is in place, we will have similar structures in farming. We will have one operator operating more than just one machine. And the operator can sit at the field border on one of the machines or in his office. This is a scenario that I have. And I think it will take some years until something like this is legally allowed. And I think this is the main hurdle currently, to find a solution, a scenario where we really can operate with bigger machines in a more or less public environment, as I see a field on a farm as public environment.
Thank you. Any of the rest of the panelists like to add to that, or will we open it up to the audience? Christian?
I get a second?
Of course you can.
Thank you. I just remember when I started to think or to talk about vision-based steering of machines. I think it was in '95. First people were talking about this, and I said it's never working, never. From my practice in the field, I had said no, it's never working. We started to invest in 2000 in this field, and now it's standard. When I think about robotics, I saw the first robot really in the field in like 2001 in the Netherlands. There was a project called Automatia or something like that. I don't remember really the year, but I think in 2002 maybe, something like that. And it's nearly 20 years as well. And I personally believe we are not too far away. We have already robots. Nayo sold many robots all over Europe, I would say, and the next step is coming soon. So I wouldn't say it's too long, but maybe you are the most interesting person here because you want a berry picking robot. And yeah, so California wants a strawberry picker for sure. Difficult. But think about milking robots. Who would believe that was possible? Like 15 years or 20 years ago, never. But it's possible. But it's also important, and it's a good example, the breeding changed a little bit. So some cows were just, they could not adapt, I would say. And for robots, it's also necessary to change the way of farming in some ways. You need other models. You need to change something. Is it to industrialize a little bit, create safety zones, whatever. There's a lot of things to do, I think.
I could say for an Indian environment, I think robot is having a good future, fit futures. The reason behind is, if you take, there is a need of labor scarcity. So the more and more experience-based labors are going off. So we need people, we need machines who will replace the labors and to improve the productivity. For classical examples, today, if you take a cotton plantations, 12.5 million hectares are under cotton in India, which is 1/3 of world land under cottons. The average yield which we are getting is 500 kg per hectare against the average of world average of 1000 kg per hectare. 10% of 12.5 million hectare is amenable for automations, robotic automations. It in turn generate the revenue of $5 million per year. Imagine that. That's what, when you ask when you need, that's what I told yesterday. The need is there, but the technology has to come up. Affordability, when the affordability will come, the farmers will really see the value behind the products. Once we start realizing the value behind the product, definitely, I think there is a clear-cut scope, and the real future is robot only.
José?
I want to complement with one more point that for me is critical, it is important, and is related to collaboration. If we want to move forward with this kind of technologies, we need to work together. We need to be collaborative. There is no way to be more effective, efficient, and agile that's working together. Even if I have competitors in front of me, we need to solve industry problems. So we should work together. So FIRA is a good example of that. Here we have people from different countries. We have probably particular differences, but our end goal is the same. So universities, farmers, startups, robotic companies must work together and be collaborative in order to be more effective, efficient, and to get the robotics working on the farm as soon as possible.
Well said, well said.
Yeah, while we've got some, I suppose, large areas in Australia, that is also our curse, because it means it makes it very difficult for producers to really know what's going on their farms. And scale actually creates its own problems. And one of the things I'm really interested in coming to this conference and looking at is to see the advances that have been made, not so much in the robotic platforms, but the way that they can be used to monitor crops, to conduct surveillance, to de-risk the production of the production system. And I think that's going to be a critical part of how we use robotics. So a robot, we think of little robot dogs, but on a farm, a robot can be the farmer's friend in terms of helping them monitor what's going on and de-risking the operations in their business, and that's going to be exciting going forward.
Yeah, we're all in agreement that this conference is collectively bringing us all together to look at robotics, and it's been a brilliant conference. Now, will we take some questions from the audience?
Does this work? Yes, okay. Oh, I'm sorry. The big white elephant wasn't mentioned.
which is the big white elephant?
Where there are 12,000 autonomous drones doing spraying, that is China. And where tens of thousands agricultural pieces of equipment are now integrated into a telematics system. So the dream of Dr. PICKEL, where somebody remotely manages a fleet of vehicles, technically is being implemented in China right now. 12,000 drones doing pesticide applications in China is 2 orders, 3 orders of magnitude bigger than what NIO has sold. Have we analyzed China enough that we feel comfortable that the discussion we've had is relevant? Or is there a possibility that within 3 or 4 years, China will come out of the corner and surprise us all with a new set of robot-based technologies, just like they did with drones?
Yeah?
I was in a conference in Sydney, Agri-Control 2019. It was mainly a mechatronics conference. It was mainly focused on academics. 50% of the participants were Chinese at that conference in Sydney. And I can say that they've made incredible advances in the development of not just aerial systems, but particularly in terms of fruit harvesting systems and monitoring systems and these things. I was pretty impressed. The challenge I do see with the use of drones in particular, as distinct from terrestrial vehicles on the ground, is that in our country, the airspace, whether it be a drone or an aircraft, is highly regulated, and the government is not, where we're not, don't have a lot of regulation on terrestrial or robots on the ground. If they're in the air, that's completely different. And when it comes to pesticide application with drones, it is quite a difficult conversation in our country. That's probably all I can say.
The African continent has about 61% to 65% of farmers. In sub-Saharan Africa alone, agriculture contributes about 28% to the GDP. Now, I would say that relatively, there's a compelling reasons for manufacturers and investors to look in that direction. So I want to ask, is there any interest in promoting robotics in Africa or for African farmers?
I think, is there any factories, Africa?
I cannot comment it really because we do not robots, but we do tools for robots, so, or tractors. That's interesting for us, I can say. Peter, maybe you have a comment.
Yeah, we discussed it at the lunch break already, so I'm not the expert for African countries, especially not for the Sub-Saharan zone in Africa. Actually, I think a gap of robotics is not the African problem. That's my opinion. I think Africa still has a problem of mechanization, and I think they need fitting mechanization. So mechanization is a key issue for developing the continent of Africa. And one machine or machine size that we presented on the AGTECHCENTRIC was a small, fully electric, battery electric tractor with 48 volt voltage level. And I think this is a technology which is really something realistically to support African needs, because you could easily adapt some PV panels to the machine to charge it with a very, very cheap inverter. You could set up for, I think, 2,000, 3,000 euro a system to run such a machine without energy supply from the outside, without diesel, just from what is available, sun, a lot of sun. And this would be a nice step to replace today's working machines, which in many, many cases still have not 4 wheels, but just 2 legs. And I think this is the right way. And of course, if you have an electric machine, one day you could consider to run it autonomously, GPS guided. This is not a technology problem, it's a question of if the business case at the specific location is fitting to the needs of the village, of the people there.
Hi there. Let's move the focus on farmers. And what about mastery of technology? And what can field crop robots can learn from the milking robot experience about mastery of technology?
Anyone want to answer that? Would mind repeating it? Has it got to do with the milking parlour? Sorry.
I mean, one of the issues we have nowadays is the mastery of technology, how farmers can learn to use these new machines and equipment. Milking robots are already in the farms since 15, 20 years, something like that, and we are getting experience on how they are dealing with new technologies, how they are integrating robots in their way of thinking farming. So what can field crop robots could learn from this experience?
I could give a comment if nobody else wants to answer. I think you're touching a really critical point. Education is a critical point. But it's not only education about the robots. We are speaking not only about robots, but about automation of the complete farm process. So this is what smart farming, digital farming, farming 4.0 is all about. Making the farm, or putting the farm into a highly automated production system. And this needs introduction of technology. We, the producers, and perhaps also governmental organizations like universities or whatsoever, consultancy organizations, we have to teach the farmers how to install and apply the technology on their farm level. This is also an obstacle to bringing this technology on short term onto, in a wide range onto the farms. It needs time. We don't have in our brains a glass fiber connector where we could put in the knowledge into the farmers. It is a process which takes a couple of years, and this is one of the reasons why I forecasted that the breakthrough of robotics, smart farming technologies, the real turning point will be reached in the second half of the next decades, while we of course today already have applications. We see day after day more solutions, more ideas, more technologies being introduced, but slowly, and we will come to the turning point in a couple of years. This is one of the reasons why I forecasted not to be too optimistic for the time frame that's given.
I understand from a producer point of view that the introduction of these technologies can create other pain points in the businesses. You know, the complexity of the technology, things going wrong, the reliability, and I was quite involved with precision agriculture since the mid-1990s, and through that evolution of the introduction of many of those technologies, which evolved into auto steer use, and now in Australia is now looking at full-blown autonomy. Through that whole journey, we've found in Australia that particularly the larger businesses have actually paid for specialist services for people to support them through that mechanism. So there's quite a complex business structure now in Australia of specialist services that provide support to producers that are actually introducing these technologies on farm. And I think that it is a lot easier and a lot less painful for a grower if they've got someone to hold their hand through the introduction of it that really knows what they're doing. And so that's been, I think, a critical component of why precision agriculture and these technologies have been adopted so highly in Australia, because we've built those service support structures to essentially take the pain away from the growers in the introduction. It's actually worked tremendously well.
Any more questions?
Yeah. Hello. Oh, you go first. Yeah, we've talked a lot about different business models, you know, from a manufacturer point of view and also from a farmer's point of view. For me, as part of a training organization, I would really like to know whether you guys see a place for training organization within the business model of robotics in the future. For example, who is going to do the services? Will it be the manufacturer itself, or will it be the service organization? And also in terms of, we've seen it in autonomous cars that parts will decrease in terms of technology. With an electric vehicle, you have way less parts in the vehicle than with a classic diesel fuel engine, for example. Do you think there might be opportunities in terms of service, or will this be a business model for the manufacturer himself as well?
Does our main manufacturer want to answer that?
Yeah, it's me again. Yeah, if you want to automate a production system, so getting rid of human workforce, you significantly have to improve the disturbance management system. And even in industrial production systems, we speak about a zero defect production, meaning that we have a machine tool, we make it, we over-dimension it so that it will not break. That's very quickly said. I think in agricultural machines we cannot do this, but we have to implement systems that foresee disturbances, breaks, repair needs, etc., so that we can react in time. So just a failure of a machine, just accidentally, unplanned, must not happen. So this is a critical point. And the other point is also really important. We need certainly workshops educated for maintaining the machines, for repairing the machines, and we need spare parts services which can react on short-term notice. This is all a big task, a challenge which is not everywhere completed. I think the big companies such as Echo or John Deere, we are prepared, we have our spare parts support, but we still need to educate workshop staff and also, of course, the operators of the machinery.
To answer to your questions, I think we do have a product training centers, but once the product is matured enough to give the trainings, there are the service stations available, but manufacturers like Echo, as you said, John Deere, I think we have a very good network. Once a business pickups, then serviceability will be easy. Serviceability, parts availability, we can able to manage. The question here is standardizations and regulation is the biggest issue over there. Once it get through for the technology of robotics, then it will easily to penetrate with them.
This issue of, I suppose, long-term serviceability of equipment is something that's come up with the grains industry in particular, and I provide policy advice to the peak body for the grains industry in engagement with government on discussion around data and agricultural chemical policy and these sorts of things. But one of the issues that's come up regularly in discussions with the producer members and of that board has been the issue of long-term serviceability of current equipment. Particularly, you end up with an ageing tractor that needs a firmware upgrade on its operating system or things like that, whose responsibility is to provide the ongoing services. So while everything's new, everything is fantastic and things are well supported, but there is a challenge as equipment becomes... I have a John Deere tractor that was built in 1936 and I can still get parts for it, which to me is a really encouraging thing. The question is, will I be able to buy a vintage robot tractor? There's a question.
I think we're running out of time. Is there any more questions? One more?
A quick one.
I think we've bored them silly. Oh.
Anybody has a question? Yes, up there. Oh, okay.
En revanche, moi, je vais la faire en français si c'est possible.
Deux secondes qu'on installe les casques.
Well, we have to bring the headsets to the listeners here. While listening to your question, I was looking at the program for today and tomorrow, and the topic for today as well. I think that robotics is definitely assaulting the world. It's a world event, and it's concerning the population. And in France, we take our time. Have you been thinking about communication for the population, training of the population? Our Australian friends tells us that the tractors are operating over there for very large farms. So the tractors can navigate independently. Now, will the people accept small robots? And a small robot works better.
On ne sait pas s'il y a quelqu'un dedans.
Small robots, people don't know there's someone inside, but people are used to seeing big tractors in our fields. It's the vision they have. Have you thought, you manufacturers of agricultural equipment and small robots, have you thought of communicating to the population why it's better to use these robots, why they perform better, why they're economically viable?
I think we have today already robots in private gardens. We have them in private houses as vacuum cleaner. I cannot see a big problem really. When it comes to bigger machines, there is problems maybe again. But from my German point of view, I cannot see a big discussion at the moment going on here. But I personally think that an open field robot in a high density population area will always be survived somehow. I'd rather think there will be maybe 5 robots and 1 person with a red knob and stop everything if necessary. I cannot believe that there will be a 300 horsepower tractor running alone in a small field surrounded by houses, to be honest.
Actually, it is a very good question. Some minutes ago, Peter talked about robotics, and then that is not only about robotics, it's digital farming. Then there is a one step forward, which is related to adoption or cultural change. So maybe the technology could be available, but if farmers, they don't know about that, or they doesn't know the advantage, or doesn't want to use them, we are not be successful. So in particular, at HORTIFRUT, we have the same challenge, because people in personal life using always technology, using social network, using Instagram, user systems, but however, for farms activities, they don't use as much technology, and they don't see that technology can help them. Therefore, there is a educational program or how to learn, how to teach them that technology is not only in one part of their life or the business, is also part of the farmer business. So there is a way to work on that, and probably it will be in parallel activity with the robotics development and digital farming developing. There's also a learning strategy that we need to develop with farmers in my case, inside of HORTIFRUT company.
The question that was asked was a very good one, and the issue of what we broadly call social license. is a really important part of the conversation. In the nearby city where swarm farm is commercialised, there's been a series of conferences, I suppose, where the issues of the introduction of these technologies have been discussed. And while there was less concern about risk and operational safety associated with robotics, it was well understood they're smaller platform robots, so that community is more accepting generally of something smaller running autonomously than something larger, and that's granted. But the big thing that was discussed in this local community was how it was going to change the social fabric of the community. How it's actually going to change employment structures, the type of individuals, the type of work that people are going to do in that community. And that's a conversation we're just starting to have in Australia, and it is quite front of mind because it will be quite disruptive in terms of how local communities in the country work together and engage with one another. And it's a conversation we need to have.
Okay. Oh, yeah.
Perhaps one comment from my side. So we have talked to many people, to farmers' associations. We are in contact with governments, not specifically about robotics, but in general about smart farming. And this, I can say in Europe, and especially in my country, smart farming, and this includes autonomous machines, robots, etc., is a hype topic on the political and social scene. If you look into the newspapers, it's really under discussion. Especially smart farming brought back agriculture into a public visibility, which we didn't know 10 or 15 years ago. So I think the topic has arrived at a public community, and the visibility of agriculture has increased positively and very much in the last decade due to these new technologies.
All right. Well, I would like to give a big round of applause to this very interesting panel. Thank you, Sinead, for moderating it. Thank you so much.